Okay, so today we're going to be using the Pythagorean theorem to find the distance between 2 points on a coordinate plane. We are also going to be determining if a Pythagorean triple is true or not. So let's take a first look at our first example. It says using the points below as the two vertices, draw a right triangle. Then use the Pythagorean theorem to determine the distance between the points and put your answer in the yellow box. So the first thing we're going to do, we're given 2 points on a graph. We're giving 1, 3, which is here, and 4, 7, which is here. So we're going to create a right triangle connecting those 2 points, okay? We're looking for C because this is a right angle, okay? So we know that our formula for Pythagorean theorem is a squared plus b squared is equal to c squared, right? So the distance from these 2 points would be C. So we're given A and B. Well, how do I figure out what A and B are? Well, I'm going to look at the units on my coordinate plane, see what my scale is going by. My scale is going by 1. So this would be 1, 2, 3, 4. And this would be 1, 2, 3. So we have 3 squared plus 4 squared is equal to c squared. Okay, so 3 squared is 9 plus 16 is equal to c squared. So 25 is equal to c squared. And then we want to get c by itself. So we're going to do the opposite of squaring, which is to find the square root. And the square root of 25 is 5. So c is equal to 5. So the distance from 1, 3 to 4, 7 is 5 units. Next, we're going to do the same thing. So if you notice, we have -3 and 3 and 2, -9. So we're going to create a right triangle. Create a right triangle and connecting these 2 points. We are looking for the distance and we have a right angle here, so we're still looking for C. We're going to count our units 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the side length is 12. 1, 2, 3, 4, 5. This side length is 5. So once again, our formula is a squared plus b squared is equal to c squared. A is 5. B is 12. So 12 squared, we're substituting in our values, okay? 5 squared is 25 plus 144 gives us c squared. 25 plus 144 gives us 169. So 169 is equal to c squared. We need to get c by itself, so we're going to find the square root because we want to do the opposite of squaring. That gets c by itself. C is equal to 13. So the distance will be 13 units. Next, we have -2, 5, -2, -5, and 3, -8. So we're going to create our right triangle and connect the 2 points. Draw my arrows because my arrow always points to C. So now I'm going to count my units, okay? 1, 2, 3. 1, 2, 3, 4, 5. I start off with my formula, which is a squared plus b squared is equal to c squared. So I have 3 squared plus 5 squared equal to c squared. 9 plus 25 is equal to c squared. So we're going to add those two together and then figure out what c squared is. So c squared is 34. 34 is equal to c squared. Well, I know that's not a perfect square, so what I'm going to do, I'm going to take out my calculator, and I'm going to find the square root of 34. And I get 5.83. I'm going to round to the nearest tenths place. So 5.8 is equal to c. So it is 5.8 units. Okay. Now we're going to take a look at triples, right? So you're given three numbers, and we want to know if this represents the side lengths of a right triangle. Well, we know a squared plus b squared is equal to c squared. We know a is our shortest side, and c is our hypotenuse. And our hypotenuse is the longest side. So we have 35, 612, and 613. So essentially, this will be A, B, and C. We're going to substitute these values in to see if it makes a Pythagorean triple or not. So we have 35 squared plus 612 squared is equal to 613 squared. So there are two ways you can do this. I'll show you the first way. We're going to figure out what each of these numbers are. So 35 squared is equal to 1225. 612 squared, 374. 544. And then we figure out what 613 squared is. 375, 769. 375, 769. So we're going to add these two together. Okay. So we're going to follow the Pythagorean theorem and add those together. And we get 375,769 is equal to 375,769. So if they end up equal to each other, then it is true. This is a right triangle. So next, we're going to try this again with a different triple. We have 2, 3, and 5. We start off with our formula, a squared plus b squared is equal to c squared. So 2 squared plus 3 squared is equal to 5 squared. 2 squared is 4. 3 squared is 9. 5 squared is 25. 4 plus 9 is 13. 13 is not equal to 25, so it is false. It is not a right triangle. It does not represent a right triangle. So you will go ahead and complete your assignment, and then you're going to also, for your exit ticket, go ahead and complete that CFA in AWARE, and have a good day.